As we start Topic 8 of Unit 3, our last section before our test, we're going to analyze arguments with Euler's diagrams. Now, a little history on this. Euler was about 100 years earlier than Venn diagrams that we used in the beginning of this unit. But Venn seemed to have taken all the thunder, and Euler is left out a little bit, but we'll study and give him a little applause for the work he's done here. So we're going to look at what is called logical arguments, arguments with universal quantifiers, arguments with existential quantifiers. Remember, we had these words earlier. And let's look at this. Now, some of this will be written up in your booklet. And here is, in a nutshell, what a logical argument is. It's made up of, and there are some key vocabulary words here, premises. Examples of premises are assumptions, laws, rules, widely held ideas, or observations. And then a conclusion. Together, premises and a conclusion make up an argument. A lot of good questions here. Now, what makes an argument valid or invalid? Well, an argument is valid if the facts that all the premises are true forces the conclusion to be true. An argument that is not valid is invalid and is called a fallacy. So here are some specific terms that are used in this lesson. Again, they should be included in your notes. Pause as needed. Now, several techniques can be used to check the validity of an argument. One of these is a visual technique based on Euler's diagrams. So here is our first example. So you'll put this on the left side of the page. This is our first example, PowerPoint slides. Write this out. Is the following argument valid? All cats are animals. Figgy is a cat. Figgy is an animal. Now, I'll do this one with you to start us off, but I'm going to use the PowerPoint slides for these because they make a much nicer circle than I can. So, what is in a sense, our universe here? And it would be animals. So we would put this animals. Now, Figgy is a cat. Where would we put that circle or subset in a sense? Well, would it be outside of animals? We're saying all cats are animals. So no, this circle would then be inside, and this would be Figgy is a cat, so to speak. So Figgy is an animal. we would put the X here to define Figgy's position within the Euler diagram. So this being fixed here makes this a valid argument. Let's look at what the book is showing us. So the diagram shows that Figgy is inside the region for animals. The argument is valid, where X represents Figgy. So you want this in your notes, a little sketch. And let's go on to example 2. Again, we're dealing with a universal quantifier. Is the following a valid argument? All sunny days are hot. Today is not hot. Today is not sunny. So let's take a look at the Euler diagram. So we're going to have the universe of hot days. We're going to have sunny days inside hot days. Today is not sunny. Notice we're negating this. And the diagram shows the position, today is not hot, X outside of Euler's diagram, but we are negating. So this is a valid argument. Again, pause and sketch. All right, for example 3, again, our PowerPoint slides. Is the following argument valid? All cars have wheels. That vehicle has wheels. That vehicle is a car. Now, our universe, or our big circle, is things that have wheels. We have cars within the circle. Cars, all cars have wheels. But the X, which represents that vehicle, could be inside the subcircle of cars or outside that subcircle, and since we do not know where it would be placed, we say this argument is invalid. So again, sketching it, reading these, because you'll have some like this for your homework. All right, for our example 4, PowerPoint slides. We're looking at a universal quantifier. Is the following argument valid? Now, notice, in this case, it's not a universal quantifier. We have some. Some is an existential quantifier. Some students drink coffee. I am a student. I drink coffee. Now, you almost have a feeling about this going into it, but let's see what the Euler diagram shows. So our big universe circle would be people that drink coffee. Now, the idea of the existential quantifier some drink coffee takes our circle to include some of the coffee drinkers and some of the non-coffee drinkers. And some students would be coffee drinkers, some would be non-coffee drinkers. So the idea is, where do you place the I? Do you place it inside the big circle, or could you place it outside? And again, when there's a question as to where you're going to place it, then that is an invalid argument. Okay, now what I've done in your booklet is I've put the examples and I've given all of the solutions for these. So you can get some extra background on why things were made and what is proper and what is not proper for something like this. So, example 1, now in our booklet, all of this is written up, so you just have to follow it. No accidents happen on purpose. Spilling the beans was an accident. The beans were not spilled on purpose. Is that a valid argument? Well, notice that accidents are things that don't, by definition, happen on purpose. So there are two separate circles for that. Now, spilling the beans was an accident. So that will be in the circle, the Euler's diagram circle for accidents. So therefore, this is a valid argument. All right, let's do example 2. All rainy days are cloudy. Today is not cloudy. Today is not rainy. We had one similar to this earlier. Let's look at our Euler's circle. So, cloudy days would be the universal circle, so to speak. Rainy days, a subcircle within that. Now, where are you going to put the X? Inside the circle or outside the circle? That is, today is not rainy. It would be outside. Now notice, it's negating rainy here. So that would be the proper place to make this argument valid. And if I were a student for the first time reading through these, I would look at these carefully, because you are building background to be able to do your homework and then later test items. Okay, let's check this one out. And it's written up in your booklet. All magnolia trees have green leaves. That plant has green leaves. That plant is a magnolia tree. So what do you think your universal circle would be? That plants have green leaves. And there we see it. Now, magnolia trees have green leaves, so they would be inside. But then looking at that plant, you don't know whether that X, which is that plant has green leaves, goes in the magnolia circle or in the green leaf circle. So therefore, there is a question. So the argument is invalid. It is a fallacy. Again, does the position of the X support the validity of the argument being, in a sense, in its proper place? Okay, taking a look at this one. All expensive things are desirable. All desirable things make you feel good. Maybe, again, we're not talking about whether something's true or not, because there's some question on that, especially this next one. All things that make you feel good make you live longer. Again, you're wondering whether or not this particular statement that's underlined, where we're going to put that X as to the validity. So our conclusion, all expensive things make you live longer. Now, so the universal big circle, things that make you live longer, things that make you feel better, according to this argument, desirable things, expensive things. Now, each premise, as they're stating here, is true. Then the conclusion must be true. But here's a case where the argument may be valid, but the conclusion may not be true. I think this is what is shown here. Things that make you live longer. Things that make you feel good. Desirable things. Now, there are conflicts in here. I'm not going to go into those, but there are some. And some of those things can be very expensive, but not necessarily make you live longer. So that's why they're saying this argument is an example of a fact that a valid argument need not have a true conclusion. All right. Again, this is all written up in your booklet. All right, let's take a look at this one. Is the following argument valid? Many students drive Hondas. I am a student. I drive a Honda. Well, this is very similar to what we did in the PowerPoint slides dealing with coffee. And again, people who drive Hondas, students, some of them are in this circle, but some are not. Where do you put the I for the person that drives the Honda? So therefore, there's a choice of places. The argument is invalid. All right, let's look at example 6. All fish swim. All whales swim. A whale is not a fish. Now, the premise leads to two possibilities. The figure 33 shows a set of fish, and the set of whales are intersecting. Well, keep in mind that that would be incorrect. Whales are mammals, they're not fish. And in figure 34 shows them separated. This would be the proper way. Both diagrams are valid interpretation of the given premises, but only one supports the conclusion. Again, I'm not sure a biologist wrote this because, in a sense, this one wouldn't apply, while this one would. So, because the truth of the premises does not force the conclusion to be true, the argument is invalid. Even though we know the conclusion to be true, this knowledge is not deduced from the premises. All right, one way to look at it. Now, there are some interesting items. If you have your textbook, they have this in there for further thought, where lawyers in court, and you've seen perhaps a lot of this going on, where people are arguing the merits of a case, and we talk about reasonable doubt is a major thing. And if we had lots of time, and if I were going to give term papers in this course, this might be something we would do more. But this is sort of interesting here to read over, and maybe of general interest for general education. But we'll wind up our lesson at this point here.